Pinpoint Weather University. Sponsored by Gaston Roofing.
Welcome back, everyone, to Queen City News Plus and Pinpoint Weather University. I'm meteorologist Andrew Brightman, and we have got a really interesting topic for you guys here as we're going to be doing our next segment, and that's going to be talking with Dr. Kelly Fast from the Planetary Defense Coordination Office. And Dr. Fast, I want to thank you so much for joining us and really being able to talk about an interesting subject. There's been a lot in the news about different celestial bodies for different reasons that we're taking a very close look at. So how does today find you, Dr. Fast?
Oh, I'm fine, and thank you so much for having me and for the interest.
Yeah, absolutely. So as we get rolling here, the first thing I wanted to start talking about is maybe something, an office that maybe many people haven't heard of before, and that is the Planetary Defense Coordination Office, and you're the Planetary Defense Officer. So could you talk to us about getting things rolling here? What exactly is the Planetary Defense Coordination Office, and what does a Planetary Defense Officer really do, Dr. Fast?
Well, NASA's Planetary Defense Coordination Office is responsible for those coordination activities across NASA and with other agencies and with our international collaborators on the issue of planetary defense, which is essentially finding asteroids before they find us and then addressing any potential threat that might be found. And so here at NASA, a lot of the activity involves funding efforts to search the skies looking for asteroids to see, is there anything that could pose an impact threat to Earth, but then also doing a lot of research on asteroids themselves and on how to address a potential threat like mission options.
Yeah, and kind of jumping into that a little bit more here, how did the Planetary Defense Coordination Office really come into being? What was the impetus behind that? I think I did a little bit of research, started up in the 90s. Why did NASA and the federal government really want to make a concerted effort to start tracking some of these near-Earth objects?
Well, NASA's been involved in asteroid research and near-Earth object research, like you said, for a long time, since the 90s. There, of course, asteroids are of scientific interest in terms of being time capsules of the early history of the solar system. But there were some events that really reminded us that impacts by asteroids, are still happening in the solar system and still could happen, even though it's very unlikely. You had the impact of Comet Shoemaker-Levy 9 with Jupiter in 1994, which reminded us that, yes, impacts are actually happening now and not just in the early history of the solar system. And then there was the Chelyabinsk impact in 2013 over Russia, a small asteroid disintegrated in the atmosphere, but still released a lot of energy. And so even though the odds of getting impacted are very low, NASA and the U.S. government and Congress took it all very seriously. And so NASA was tasked with inventorying the asteroids and comets that come into Earth's neighborhood and could pose an impact threat to Earth. And so that's been the driver for what NASA's been doing, which then became formalized into the Planetary Defense Coordination Office in 2016. But all throughout, just the process of finding asteroids, tracking them, figuring out where they're going to be in the future, and researching options for either estimating their impact effects or how could you deflect them and avoid an impact altogether. And to accelerate all of that, NASA has been developing its Near-Earth Object Surveyor Space Telescope mission, which in concert with the telescopes on the ground is really going to speed things up. And then you probably remember from a few years ago, NASA's DART mission, Double Asteroid Redirection Test, actually testing a deflection technique. So trying to keep things moving with the survey. You can't do anything about a threat if you don't know about it, but also trying to get some of the tools in the toolbox ready should one be identified.
Yeah, and one of the things when we talked about the PDCO being formalized in 2016 is that you guys are tasked with trying to find every common asteroid that is 140 meters in size or larger. As you and I both know, the solar system, the Oort cloud, the Kuiper belt, it is huge. How difficult how grand of a task is that really to try to find and track all of these objects?
Well, I've always heard that line, how do you eat an elephant? One bite at a time.
Yeah.
And the original tasking to NASA was for the 1 kilometer and larger asteroids, and that population is pretty much in hand now. And so now the bar is set at 140 meters and larger for the near Earth asteroids, the asteroids that come into Earth's neighborhood.
Yeah.
And but the thing is, just because that's kind of the metric that we're measuring against doesn't mean we're not trying to catalog anything that could be found that comes into Earth's neighborhood. And so certainly the asteroids that have originated in the main belt, the asteroid belt, and have made their way into the inner solar system because over time getting tweaked by Jupiter's gravity and whatnot, there's that population that it poses a much higher hazard to Earth than, like you mentioned, like the Oort cloud, like maybe a comet coming from the Oort cloud, for the first time in thousands or millions of years. To That would be such a rare thing for it to actually line up with Earth. And so we certainly want to find and track and put in the catalog anything that comes into Earth's neighborhood. But the near Earth asteroids are the population that poses the greatest hazard and is kind of the metric that we're measuring ourselves by and that Congress is measuring us by to make sure that NASA is bringing its capabilities to bear on the hazard and getting it characterized.
So basically what you're telling me is that you're almost a victim of your own success tracking. I think at 98% of all asteroids, at least a kilometer across, you guys have tracked, got an orbit on, making sure it's not going to impact the Earth. So basically you want to almost challenge yourselves a little bit and kind of getting in there a little bit more. I want to talk about, so for someone like you, Dr. Fast, how does someone become a planetary defense officer? It sounds like an amazing, a very cool job to have. Like for me as a meteorologist, it's pretty relatively straightforward. So if you could just tell me a little bit about, what was your career like? How did you become a planetary defense officer?
My predecessor, Lindley Johnson, he had been thinking on planetary defense a long time, even before he came to NASA. So he's one who really had a vision for that. For me, it's something that I kind of found myself in later on. I started as an astronomer. I was an amateur astronomer. I had a telescope that I grew up in Hollywood, California, in LA with the city lights, but I still loved taking the telescope out and I could see the planets from out there. And as I went through my education at UCLA and at University of Maryland and then worked at Goddard Space Flight Center, I was kind of reminded, that's what I loved as a kid, the planets, in the solar system. And so I did a lot of research, planetary astronomy, looking at things inside our solar system, and some of it in coordination with missions, but doing planetary science. And then when I came to NASA headquarters, managing programs related to planetary astronomy and planetary science, I started working with Lindley Johnson on the Near Earth Object Observations program. And I kind of joke and say, and one day I woke up and I was managing the program. But for the past decade or more, working with that program and managing the projects that do the astronomy, that do the science, but that science that's applied to protecting people's everyday lives, essentially, for something that is a very low likelihood but could have a high consequence. And so with Lindley Johnson, with his retirement, I was made the acting planetary defense officer. And so I've kind of had that time to experience different parts of research throughout the solar system and management here at NASA headquarters. And now in this role where I always say my role is to kind of support everybody out there doing the real work. I don't get to go to the telescope myself anymore, but I do get to manage a fantastic program with amazing people in it who are out there every night, doing this work from observatories. They're doing orbit determination, they're doing research, they're doing mission design. So an amazing team of people. In fact, a few months ago, NASA released a documentary called Planetary Defenders. It's on the NASA Plus streaming platform, and I think can be found on Netflix now, and it's on YouTube. And it really gives a nice overview and shows some of the faces those who are out there doing that day-to-day work. So I ended up finding myself with a very cool title, and I'm very grateful for that. But it's only because of some amazing people who are out there doing that work that they're supporting me, but I feel like I'm supporting them, and I'm very proud to do that.
No, I mean, it's absolutely fascinating. It's a much cooler job than me. Again, I have a little less noble interest. And again, I grew up when I was a kid. I saw the movie Deep Impact and Armageddon, and that always kind of brought me interest. And that's why I always wanted to talk to people like you. And it's just really fascinating learning your career history. When we come back, we're going to be talking more about some of these near-Earth objects that the Planetary Defense Coordination Office is tracking right now, some of their names, and just some of the interesting facts behind it. We'll be right back after the break. Welcome back, everyone, to Pinpoint Weather University. I'm meteorologist Andrew Brightman. I'm very lucky to be joined with Dr. Kelly Fast, who is the Planetary Defense Officer with the Planetary Defense Coordination Office. And we were just talking about the history of the office, your career history. But let's start talking about some objects that have been in the news recently. The first one I wanted to talk about is Asteroid 2024 YR4. I got to be honest, Dr. Fast, we got to work on some of these names here. But I wanted to talk about, how was this asteroid discovered? You were telling me about how these bodies are tracked, but we're talking about a relatively small asteroid in a celestial sense. What is the history behind the discovery of this asteroid?
Right. Well, 2024 YR4 was first picked up through normal survey operations. We have a number of surveys, telescopes that have wide fields of view that look at big swaths of the sky, looking for moving objects. And an asteroid in the telescope just looks like a point of light, just like the stars, except it's moving relative to the stars. And so it was first picked up by one of the surveys, the NASA-funded Atlas survey of the University of Hawaii, their station that is down in Chile, picked up this asteroid, and it did what it normally does. It reports observations to the Minor Planet Center, which is the international clearinghouse for position measurements of small bodies that NASA also funds. But over time, as those position measurements came in, and as the orbit determination was done by the JPL Center for Near-Earth Object Studies, it became evident that this asteroid, the observations here in 2025, if you extended that all the way to 2032, there was a small chance that it could impact the Earth. And that happens all the time. And then more observations then shrink that uncertainty, and then you find out, oh, it's not a problem. But this one, the uncertainty was wrapped right around the Earth in 2032. And so it took a little while to retire that risk to Earth. But it was an interesting process to go through because it was significant in that it was the first time that an object that could do damage had risen up to a level that required NASA to notify within the U.S. government, and also to notify the UN Office of Outer Space Affairs as part of its role leading the International Asteroid Warning Network. The data are all public. Everybody can see it anyway, but NASA has these formal roles to roll up the information and convey it properly. And so it was a chance for us to go through that process, even though we knew it was a low probability and that over time we might find out that the uncertainty would shrink off the Earth. And that's what ultimately happened. Yep. But we didn't know until we knew. And it was very important to go through all that, to continue taking observations, to continue tracking it here in 2025 until we could find out that in 2032, there's no way that it could impact the Earth. And so at this point, we know it's going to be fine. It's going to fly by Earth in 2032. And that just showed the system, both NASA funded and in the US and also internationally working together. But as you've also noted on your slide there, that there still is a small chance that it could impact the moon. The moon is still in that area of uncertainty that has remained for 2024 YR4. It's not a very large asteroid. It's estimated to be about 60 meters or 200 feet across. And it's not going to hit the Earth, and so now it kind of becomes interesting scientifically.
It really does.
But we have to wait. We have to be patient. It's the type of situation we didn't want to find ourselves in with the Earth, to kind of have this uncertainty and then not know, because we can't observe it now. It's kind of it's on its orbit going way out further in the solar system. Then it's going to swing back in again in 2028, and we can get more observations then. And then maybe we can have this interview again.
Yeah, basically every 4 years. So basically, is it like, does it have a 4-year orbit, excuse me, around the sun? I was just curious what the orbital period is. What is the orbital period for
Right, it's about 4 years, and so we play this game of tag with it around the sun, and it's been in the inner solar system before, but we've been at different spots of our orbit when it has on that orbit when it's made its way in. And so we've been too far away from it, or it's been the daytime sky, or it's been too faint to detect. And so this was the time where, we got it. It was bright, and we saw it, and we went, okay, we got to pay more attention to this one.
Gotcha. And so as we were talking about the moon, so obviously it's not going to impact the Earth at this point, but there's roughly a 4% chance, 1 in 25. If it ever got to the point where it was significant, let's say it got up to 20, 30, 40, 50% of hitting the moon, would there be a discussion of whether, I'm just trying to think of what type of impact would that be if it actually did impact the moon, because there's no atmosphere, there's nothing to slow it down, disintegrate it at all. I guess I have a kind of a multifaceted question. So would there be a discussion with the president or the powers that be, should we try to deflect this asteroid? And then also, would we be able to see the impact from the Earth's surface with the naked eye if it did make an impact on the moon?
Well, since the probability is so low, it's still very early on in looking at a lot of that. And NASA's Planetary Defense Coordination Office, our role is really getting all of that information so that we know what to plan for. Our responsibilities to maintain custody of that object and to figure out where it's going to be in the future. And so if we find that the probability continues to go up as we get more observations, then I can imagine more of those conversations happening. From a point of view of like mission development, it's not something that could be done on a very short time scale. And so that may or may not be a possibility. And again, it's not something that is affecting, something that is going to hit the surface of the Earth. So we're really kind of still at that information gathering point. And then we, as the Planetary Defense Coordination Office, would engage with others on conveying the information we have so that they can make decisions for their mission areas as need be. So it's still kind of in a stay tuned type state, but it's an interesting exercise and a lot of good questions that come up as we already learned a lot of lessons just going through this process, which is why we've been trying to get things in place in the first place to be able to answer some of those questions.
Yeah. So, but would we, like, I'm just trying to think if there was an impact, hypothetically, if there's a full moon hit that side, would we be able to see like the impact, the ejecta from the moon surface from the Earth during the nighttime? I'm just trying to think of what it would look like from Earth seeing this.
Well, certainly the energy released, there were already by cameras that monitor the moon, you see flashes by very small impacts that hit the moon. So there would be energy released. In this case, there'd be a lot of energy released. So certainly a flash would be visible. It would be on this side. How that would work with the brightness of the moon, just for the naked eye, I don't know offhand.
Yeah.
Haven't looked at that or looked at the model of that.
Oh, yeah.
And then there's the ejecta. But certainly it was with Comet Shoemaker-Levy 9 and Jupiter, it was kind of an interesting process of making predictions and then seeing what actually might happen. So for the scientists, it's very, very interesting. But again, we're still at this very low probability state, so we'll have to see how it plays out. But then it would certainly be something of great public interest, if we did find out that the probability goes up.
Absolutely. So that's what we have on Asteroid 2024 YR4. But after the break, we're going to be talking about an object that is from outside the entire solar system. We're going to be talking about one more very interesting celestial body coming up right after the break on Pinpoint Weather University. Welcome back to Pinpoint Weather University, everyone, on Queen City News Plus. I'm meteorologist Andrew Brightman, joined with Dr. Kelly Fast, the Planetary Defense Officer. Now, Dr. Fast, we're talking about one more celestial body, and this one comes from outside of the solar system. Very recently, we have discovered an interstellar comet asteroid that has made its way into the solar system. What can you tell everyone about this newly discovered object?
That's right. This was just last week as we record this. There have been two other objects, small bodies that were discovered previously that, based on their orbits, it was found that, you know what, these came from outside our solar system and they're passing through and they're going to leave our solar system again because they were moving so fast. The speeds and the orbits indicated, or the trajectories indicated, that they did not originate in our solar system. The first was Oumuamua, and the second was Comet Borisov. And so this third one just happened last week. The same University of Hawaii NASA-funded Atlas station in Chile that we just spoke about, that first observed asteroid 2024 YR4, also reported this object last week. And again, through a normal process, it reported observations to the Minor Planet Center, but even based on some of those initial observations, it was evident pretty quickly that it was moving at such a speed that it was of interest. And researchers went and looked at earlier observations that were taken by Atlas when it covered the same part of the sky, and other telescopes called those pre-coveries, or sort of the discovery observations, because maybe they're really faint, they didn't get picked up in the normal process, but by doing that, it was possible to connect that orbit back like 2 weeks.
Wow.
And so things happened very quickly because, based on all of that, it was evident that, again, here was the third known interstellar object. And the data are public. So so the news started building up very quickly, even before the Minor Planet Center issued its confirmation that, yes, this was a newly discovered object. It was an interstellar object, and it showed cometary activity, meaning it showed a bit of a coma. So meaning there was some dust ice activity. And so it was designated as the third interstellar object, this comet Atlas. And so now it's of, again, high scientific interest because it poses no impact threat to Earth. It's when it passes closest to Earth, it's still almost the distance from the Earth to the sun away from it.
Yeah.
And so now telescopes observing it, because here we've got another object that originated outside the solar system. We want to study its properties. Scientists want to study what is it made of, what is its composition, what's its rotation, behavior. So a lot of that is happening right now with facilities around the world, and so it's a cool example about how planetary defense, the process of trying to find out, could something pose an impact threat to Earth, we get a lot of cool scientific discoveries out of it too. So now we can kind of have fun with this and really enjoy delving into the science on it. And there have been 3 now, and so there will be more to come, I'm sure.
So when we think about Comet, I'll just call it Comet Atlas. When we think about Comet Atlas, so how do you know basically that it's not an Oort cloud object? Because, again, me being a nerd myself, is that the Oort cloud goes out, I think, almost 1 to 2 light years out from the sun. So you can have extremely long period comets that have orbital periods of multiple millions of years and have very, very long elliptical orbits. What makes the determination that Atlas is truly from another star system? And how does an object sort of get thrown out of another star system and can make its way through interstellar space and into our solar system?
Well, that's a very good question, because that is something that should be asked. Are we just discovering something that originated in our own solar system?
Yeah.
And just like with a spacecraft, you can travel very close to the Earth or another planet and get a gravity assist, and you can get sped up and you can get flung faster. The same things happens with small bodies. And so it's possible that a comet from the Oort cloud, like you say, could come into the inner solar system and maybe get flung around the sun and accelerated, and maybe even flung out of the solar system. And we might observe it and think, oh, it's on its way out of the solar system. Maybe it came from outside the solar system. The teams that do orbit determination, they look very closely at all of this to make sure that something might not be, that one of these might not be something that did just originate in the solar system and maybe is getting ejected and then might end up in somebody else's solar system. They were looking at the trajectory, they were looking at the speeds, and there was enough evidence there to say that now this originated from outside the solar system. It was going too fast for it to have been something that was just tweaked in from the Oort cloud, and it's going to be ejected again. But it's a very good question, because we want to make sure that we're not just putting labels on these that don't fit.
Awesome. Just absolutely fascinating stuff. So just really appreciate your time speaking with us today, Dr. Fast. But that is going to do it here for our latest edition of Pinpoint Weather University. I'm Pinpoint meteorologist Andrew Brightman. So lucky to be joined today with Dr. Kelly Fast, the Planetary Defense Officer, talking all things about near-Earth objects out in space. Thank you so much for your time today, Dr. Fast. It was wonderful to have you.
Now, thank you for having me. Thanks for being on the front lines of science and your role as a meteorologist. I think that's fabulous. Thank you.
I really appreciate it. And we'll be back next time with our next episode of Pinpoint Weather University. Take care, everyone.
Queen City News Plus. Just search Queen City News on your smart TV's app store.